Imagine a universe not so different from our own, where a seemingly insignificant decision you made years ago unfolded in a completely different way, leading to a life drastically altered, a life lived by you. The very notion sends ripples of both fascination and existential unease down the spine. Could there truly be other versions of ourselves living out alternate realities in parallel universes, making different choices, forging different destinies? This isn't merely a concept ripped from the pages of science fiction novels or the silver screen. While captivating stories of parallel lives have fueled our imaginations for decades, the multiverse, the idea that our universe is just one among a potentially infinite number of others, is increasingly becoming a serious topic of exploration in theoretical physics. It's a concept that challenges our understanding of reality itself, forcing us to confront the possibility that our existence, our very identity, might not be as unique as we believe. From the earliest days of human civilization, whispers of alternate realities have echoed through myths, legends, and philosophical musings. Think of the ancient Greek concept of atomism, the idea that reality is composed of fundamental, indivisible particles constantly rearranging themselves. While not a direct precursor to the multiverse, it planted a seed of recognizing the possibility of infinite combinations and possibilities. Then consider the butterfly effect, the idea that the smallest change can lead to the largest consequences. In a way, what if scenarios are what drove human minds to where they are now, long before equations and complex calculations came into play? Our ancestors grappled with the fundamental questions. What if things were different? What if I had chosen a different path? These questions are not new, and they are at the heart of the multiverse concept. They reflect a deep-seated human curiosity about the infinite possibilities that life, and indeed the universe, might hold. The yearning to explore the roads not taken, to glimpse what might have been, is as old as humanity itself. But how did these ancient ponderings evolve into a testable scientific proposition? How did the realm of speculation transition into the domain of theoretical physics? How can anyone prove any of this? It started in the subatomic world with the strange behavior of particles that seem to be in multiple places at the same time. Prepare to question everything you thought you knew about your place in the cosmos, for the answers may lie beyond the confines of our own universe. The question then is, how did these whispers from the past, these echoes of what if, find their way into the precise language of mathematics and the rigorous scrutiny of scientific experimentation? What events, what philosophical leaps pave the way for a concept as audacious as the multiverse? Consider, for instance, the ancient Greeks. Far from just inventing democracy and perfecting the art of sculpture, they were also deeply engaged in exploring the very nature of reality. Democritus, living over 2,000 years ago, proposed that the universe was made up of tiny, indivisible particles he called atomos, or atoms. While his vision differed drastically from our modern understanding of atomic structure, the core idea, that reality is built from fundamental, constantly rearranging components, laid a cornerstone. It suggests that the universe is not a fixed, static entity, but rather a dynamic, ever-evolving system with infinite potential for variation. If the atoms can only be rearranged once, then what else could happen if they were rearranged for a second or third time? Centuries later, the Roman poet and philosopher Lucretius elaborated on these ideas in his epic poem De Rerum Natura, or On the Nature of Things. He envisioned an infinite universe filled with countless worlds, some similar to our own, others utterly different. Think about it for a moment. In a universe without boundaries, without end, why should our world be the only one? Lucretius's vision, though lacking the mathematical framework of modern cosmology, dared to imagine a cosmos teeming with unseen possibilities. It also was the first time anyone thought so literally about an infinite universe. And let's not forget the enduring power of storytelling. From ancient myths to medieval folklore, tales of parallel realms and alternate realities have captivated the human imagination. Consider the Celtic legends of the otherworld, a mysterious realm existing alongside our own, accessible through hidden portals or by crossing certain thresholds. Or picture the intricate cosmologies of various indigenous cultures, which often feature multiple layers of reality, each inhabited by different beings and governed by different rules. Why are there so many different stories in the first place if the human race is so similar? These stories, while not scientific theories, serve as crucial expressions of our innate curiosity about the unknown. They are imaginative explorations of possibilities born from our deep-seated desire to understand our place in the universe. They ask the fundamental question, what if there's more than meets the eye? What if the reality we perceive is just one facet of a much larger, more complex, cosmic structure? Even in the realm of what we now consider early science fiction, the seeds of the multiverse were being sown. As early as in the 1800s, writers like Edgar Allan Poe, with his evocative and mind-bending imagery, began to explore the limits of human perception and the potential for alternate states of existence. What if our universe is not alone, but simply one of an infinite series of universes? Could we ever see what is beyond? These early explorations, driven by imagination and philosophical inquiry, were not constrained by the limitations of scientific instruments or mathematical models. They could freely explore the boundless realms of possibility, laying the groundwork for the more rigorous, evidence-based investigations that would follow. They demonstrated the human capacity to imagine beyond the confines of the known world, to conceive of realities far stranger and more wondrous than anything we could directly observe. It was the power of storytelling, the philosophical arguments, and the endless questioning that would take us to the next stage. The road from these ancient musings to the cutting edge of theoretical physics is long and winding, filled with countless discoveries and paradigm shifts. But the connection is undeniable. These early explorers of the imagination dared to ask the big questions, to challenge the conventional wisdom, and to push the boundaries of human understanding. And so, it was with these conceptual seeds planted, the stage was set for a revolution in our understanding of reality itself. A revolution sparked not only by mathematical equations but also by the enduring power of human curiosity and the unyielding desire to explore the infinite possibilities of existence. What will happen next? But how do you even begin to look for something like a parallel universe? Where do you start searching for echoes of yourself in the vast cosmic expanse? The answer, perhaps surprisingly, lies not in telescopes pointed at distant galaxies, but in the bizarre and counterintuitive realm of the very small, the world governed by the laws of quantum mechanics. Imagine a world where the rules you experience every day, the rules that dictate how a baseball flies or how a car accelerates, simply don't apply. A world where things can be in two places at once, a world of pure potentiality. This is the quantum realm, a place so strange that even Albert Einstein himself struggled to fully accept its implications. Think about it this way. In our everyday experience, a coin is either heads or tails, right? But in the quantum world, a particle, like an electron, can be both at the same time, existing in a state of what's known as superposition. It's as if the coin is spinning in the air, showing both heads and tails simultaneously until you actually look at it. Only when observed does the electron choose a definite state. It is no longer both, but only one of the states. Before you make a measurement or look at it, it is a mixture of possible values of properties of the particle. Now, you might be thinking, okay, that's weird, but what does it have to do with the multiverse? Well, this seemingly bizarre behavior is precisely what gives rise to one of the most compelling theories about the existence of parallel universes, the many worlds interpretation. But before we dive into that, let's take a closer look at the concept of superposition. Superposition is, in effect, where the multiverse possibilities begin. If one particle can be two states at once, where does that end? Consider the electron, a fundamental particle of matter. According to quantum mechanics, this tiny entity doesn't have definite properties, like position or momentum, until we measure them. Instead, it exists in a blurry state of possibilities, a superposition of all potential locations and speeds. Now, think of it like a ghostly cloud, spread out over multiple locations simultaneously. It is not in only one place at a time. It exists as a mixture of possible locations until you are the one who looks to measure its position. Until we make an observation, the electron is essentially in multiple places at once. It's a mind-bending concept, but it's been repeatedly confirmed through countless experiments. Scientists have even managed to put larger objects like molecules into superposition, though it doesn't last very long. This isn't something that is easily grasped, and not everyone agrees on what is truly happening when a particle is in superposition. But this opens the door for understanding the mysteries of the multiverse. Superposition leads us to uncertainty. Quantum uncertainty, also known as the Heisenberg uncertainty principle, tells us that there is a fundamental limit to how precisely we can know certain pairs of physical properties of a particle, such as its position and momentum. The more accurately we know one, the less accurately we can know the other. It's not a matter of technological limitations. It's a fundamental property of the universe. Imagine trying to pinpoint the location of a buzzing bee. The moment you get close enough to accurately determine its position, it flits away, changing its momentum and making your measurement obsolete. The same sort of thing happens with quantum particles. The very act of measuring one property inevitably disturbs the other. The more you know about one, the less you know about the other. This uncertainty isn't just some abstract mathematical concept. It has real-world consequences. For example, it plays a crucial role in the behavior of nuclear fusion in the Sun, the process that generates the light and heat that sustains life on Earth. It also has implications for the design of electronic devices. So, what does it all mean? What are we to make of this strange and unpredictable world of quantum mechanics? One thing is clear. The subatomic realm operates according to rules that are fundamentally different from our everyday experience. And this difference, this strangeness, is the key to unlocking some of the deepest mysteries of the universe. Are you beginning to see how that is all tied to the multiverse? But the question remains, is this simply a quirk of the microscopic world, or does it have larger implications for our understanding of reality? Does the quantum realm hold clues to the existence of other universes, perhaps universes where the laws of physics themselves are subtly different? Universes where other versions of you might be living out entirely different lives? The implications, if true, would be nothing short of revolutionary. Prepare to go beyond the looking glass, because things are about to get even stranger. But if quantum mechanics is so strange, so seemingly detached from our everyday experience, how can it possibly hold the key to understanding something as vast and mind-bending as the multiverse? The answer, perhaps surprisingly, lies in a theory that dares to take the implications of quantum mechanics to their most logical, and some might say most absurd, conclusion. Imagine a young, ambitious physicist, brimming with revolutionary ideas, challenging the very foundations of quantum theory. That was Hugh Everett III. In 1957, as a doctoral student at Princeton University, Everett proposed a radical interpretation of quantum mechanics, one that would forever change the way we think about reality. He called it the Many Worlds Interpretation, or MWI. Everett was wrestling with a fundamental problem in quantum mechanics, the problem of measurement. Remember that electron that exists in a superposition of multiple states until we observe it? What happens when we actually make a measurement? Why does it suddenly choose one state over all the others? The conventional explanation at the time was something called wave function collapse. It was the assumption that the very act of measurement forces the quantum system to snap into a single definite state. Everett, however, found this explanation deeply unsatisfactory. To him, it seemed arbitrary, an artificial addition to the elegant equations of quantum mechanics. His solution? Ditch the collapse altogether. What if, instead of collapsing, every quantum measurement causes the universe to split into multiple parallel universes? In each of these universes, one of the possible outcomes of the measurement is realized. Let's say you're deciding whether to have coffee or tea in the morning. According to the many worlds interpretation, the universe splits at that very moment. In one universe, you choose coffee, and in another, you choose tea. Both universes are equally real, equally valid. Now, extend this idea to every quantum event that happens, not just in your kitchen, but throughout the entire universe, every single moment. The universe is constantly splitting, branching out into an exponentially growing number of parallel realities, each representing a different possible outcome. It's a cosmic branching tree, with each fork in the road representing a quantum decision point. Think of Schrödinger's cat, the famous thought experiment. The cat is in a box with a radioactive atom, which has a 50% chance of decaying. If the atom decays, a device will release poison, killing the cat. Before we open the box, quantum mechanics says the cat is in a superposition of being both alive and dead. Everett's interpretation says that instead of the wave function collapsing, the universe splits. In one universe, you open the box and find a living cat blissfully unaware of its brush with death. In the other universe, you open the box and find a dead cat. Horrifying, yes, but equally real. The core mechanic of MWI is that every quantum measurement creates new universes. The implications of this are staggering. Every single quantum event, from the decay of a radioactive atom to the interaction of particles in your brain, triggers a split, creating new universes that are distinct but equally real. The number of universes in this multiverse is constantly growing, branching out into an unimaginable number of possibilities. Every possible outcome becomes reality, somewhere. So in one universe you might be reading this very text. In another you might have decided to pursue a career as a concert pianist. In still another you might have become a world-famous astronaut. And in yet another you might not even exist at all. Infinite copies, infinite choices. It's a mind-boggling concept, one that challenges our most basic assumptions about reality. But Everett's many worlds interpretation offers a compelling, albeit unsettling answer to some of the deepest mysteries of quantum mechanics. It forces us to confront the possibility that our universe is not unique, that we are just one of countless versions of ourselves living out different lives in a vast, ever-expanding multiverse. But if every possibility is realized somewhere, what are the limits of this cosmic branching? But if every possibility is realized somewhere, what are the limits of this cosmic branching? Can we even begin to comprehend the sheer scale of this ever-expanding multiverse? To truly grapple with the implications of the many worlds interpretation, we need to delve into one of the most famous and unsettling thought experiments in the history of physics, one that involves a cat, a box, and a healthy dose of quantum weirdness, Schrödinger's cat. Picture this. It is 1935. The world is on the brink of another global conflict, and in the quiet world of theoretical physics, minds are wrestling with the bizarre implications of quantum mechanics. Erwin Schrödinger, a brilliant Austrian physicist, is deeply troubled by the many worlds interpretation, and he devises a thought experiment to illustrate what he sees as its absurdity. He imagines a sealed steel box. Inside the box, there is a cat, a flask containing a deadly poison, and a radioactive atom. The atom has a 50% chance of decaying within 1 hour. If the atom decays, it triggers a mechanism that breaks the flask, releasing the poison and killing the cat. If the atom does not decay, the cat lives. Now here is the crucial question. What is the state of the cat inside the box after 1 hour? According to classical physics, the cat is either alive or dead. There is no in-between. But according to quantum mechanics, before we open the box, the atom exists in a superposition of both decayed and not decayed states, and because the cat's fate is linked to the atom, the cat itself is also in a superposition of being both alive and dead. It's as if the cat exists in a ghostly limbo, neither truly alive nor truly dead, until we open the box and observe it. This is where Schrödinger's cat becomes such a puzzle and an enigma to those who seek to explain it. This thought experiment highlights the bizarre implications of quantum superposition when applied to everyday objects. We are used to things being in definite states. A light switch is either on or off, a door is either open or closed. But in the quantum world, things can be both at once. And Schrödinger's cat forces us to confront this strangeness on a macroscopic scale. How can a cat be both alive and dead simultaneously? It defies our intuition, our common sense. So, what does this all mean for the multiverse? Well, according to the many worlds interpretation, there is no wave function collapse. When we open the box, the universe doesn't suddenly choose one outcome over the other. Instead, the universe splits into two separate universes. In one universe, you open the box and find a living cat purring contentedly. In the other universe, you open the box and find a dead cat, a tragic victim of quantum uncertainty. Both universes are equally real, equally valid. There is no single correct outcome. Every possibility is realized in its own separate reality. The cat never truly existed in the superposition, but instead two different instances of the cat were created when the box was opened. Now imagine the implications of this thought experiment applied to your own life. Every decision you make, every choice you face, could be seen as a quantum measurement, causing the universe to split into multiple branches. In one branch, you choose to pursue your dreams, and in another, you choose to play it safe. In one branch, you meet the love of your life, and in another, you remain single. In every possible scenario, a new universe springs into creation. It's a mind-bending concept, one that challenges our fundamental understanding of reality. But Schrödinger's cat, this seemingly simple thought experiment, reveals the profound connection between quantum mechanics and the possibility of a multiverse. It forces us to ask, is our universe truly unique? Or are we just one of countless versions of ourselves living out different lives in an infinite sea of possibilities? Is there an end to it, or can it be tested? The question may just drive the curiosity for further research. But even if Schrödinger's cat leads us to contemplate infinite branching realities, the question lingers. What triggered this cosmic explosion of universes in the first place? What event, what primordial force set the stage for this grand, multi-universal drama? To find the answer, we must journey back to the very beginning, to the universe's first fleeting moments, a period shrouded in mystery and governed by forces beyond our complete comprehension. Imagine the universe not as it is today, vast and expanding, filled with galaxies and stars, but as an infinitesimally small point, hotter and denser than anything we can possibly conceive. This is the singularity, the moment before the Big Bang, the enigmatic starting point of our cosmic journey. Now hold that image in your mind and consider the theory of cosmic inflation. Cosmic inflation proposes that in the first tiny fraction of a second after the Big Bang, the universe underwent a period of exponential expansion, a growth spurt of unimaginable proportions. In a time shorter than it takes for light to cross an atom, the universe expanded by a factor of at least 100 trillion times, stretching from subatomic size to something approaching the size of a grapefruit. It's a concept that seems ripped straight from science fiction, but it's supported by a wealth of observational evidence. Think about it, a balloon inflating at an incomprehensible rate. But what drove this rapid expansion? What fueled this cosmic growth spurt? The answer, according to many physicists, lies in a mysterious energy field known as the inflaton field. This field, permeating the early universe, possessed a tremendous amount of energy, driving the expansion like a runaway train. But here's where things get really interesting. Just as a pot of boiling water can produce bubbles, cosmic inflation may have spawned countless separate bubble universes, each with potentially different physical laws. Imagine a vast cosmic sea, not of water, but of space-time itself, filled with countless bubbles, each a self-contained universe expanding and evolving independently of the others. Each bubble universe is a separate reality with its own unique set of physical constants, its own fundamental particles, and perhaps even its own version of you. Our universe, the one we inhabit, is just one of these bubbles, a tiny speck in an infinite cosmic foam. In some of these bubble universes, the laws of physics might be subtly different. The force of gravity might be stronger, the speed of light might be slower, or the fundamental particles might have different masses. In other bubble universes, the differences might be far more extreme, with entirely different laws of physics altogether. Could there be bubble universes where stars never formed, where galaxies never coalesced, or where life as we know it is simply impossible? Absolutely. The possibilities are truly endless. And what about the shape of these universes? Are they all spherical, like bubbles? Or could some be shaped like donuts, pretzels, or even more bizarre geometrical forms? Some theories suggest that these bubble universes can collide, leaving detectable marks on the cosmic microwave background, the afterglow of the Big Bang. Imagine two bubbles bumping into each other, creating ripples in the fabric of space-time, cosmic fingerprints that could reveal the existence of other universes. Scientists are actively searching for these fingerprints, poring over data from telescopes and satellites, hoping to catch a glimpse of another universe colliding with our own. But even if we never find direct evidence of these bubble universes, the very possibility of their existence forces us to reconsider our place in the cosmos. Are we truly alone? Or are we just one of countless civilizations, scattered across an infinite sea of universes, each with its own unique story to tell? The search for answers continues, pushing the boundaries of our understanding and challenging our most basic assumptions about the nature of reality. So, if our universe is but one bubble among potentially infinite others, what exactly determines its properties? And could the answer to that question hint at an even grander, more profound understanding of the multiverse? So, if our universe is but one bubble among potentially infinite others, what exactly determines its properties? And could the answer to that question hint at an even grander, more profound understanding of the multiverse? Prepare to enter a realm where the fundamental building blocks of reality aren't point-like particles, but incredibly tiny, vibrating strings. Welcome to the elegant and often perplexing world of string theory. Imagine for a moment that everything you thought you knew about the universe, about matter and energy, about space and time itself, is about to be turned on its head. What if the particles that make up everything around us, from the smallest atom to the largest galaxy, aren't actually particles at all? What if they are, in fact, minuscule strings, vibrating at different frequencies, like the strings of a cosmic violin? String theory, in its simplest form, proposes that the fundamental constituents of reality are not zero-dimensional point particles, but one-dimensional extended objects, these incredibly small strings. Now, when physicists say small, they mean really, really small. We're talking about the Planck length, a distance so tiny that it makes an atom look like a vast galaxy. It's something close to 1.6 times 10 to the minus 35th meters. That's a decimal point followed by 34 zeros and then a 1/6. These strings, far too small to be seen with even the most powerful microscopes, vibrate in different modes, each mode corresponding to a different particle. It's like a guitar string that can vibrate at different frequencies, producing different musical notes. In string theory, each vibration of the string corresponds to a different particle, a different force carrier, a different aspect of reality. One vibration might produce an electron, another a photon, and still another a graviton, the hypothetical particle that carries the force of gravity. But why strings? Why not just stick with particles? Well, string theory offers a potential solution to one of the biggest problems in modern physics, the incompatibility between general relativity, which describes gravity on a large scale, and quantum mechanics, which describes the behavior of matter at the subatomic level. These two theories, the cornerstones of our understanding of the universe, simply don't play well together. When physicists try to combine them, they get nonsensical results, infinities that render the equations useless. String theory, however, offers a way to reconcile these two seemingly disparate theories. By replacing point particles with strings, it smooths out the infinities and provides a consistent framework for describing gravity at the quantum level. It's a bold claim, but it's one that has captivated physicists for decades. There is another theory that is called M-theory. It is the successor to string theory. But there's a catch, a rather large catch. In order for string theory to work mathematically, it requires extra spatial dimensions beyond the three we experience in our everyday lives: length, width, and height. According to string theory, the universe may have as many as 10 or even 11 dimensions. But where are these extra dimensions? Why can't we see them? The answer, according to string theory, is that these extra dimensions are curled up, compactified, at an incredibly small scale, far too small to be detected directly. Imagine a garden hose. From a distance it looks like a one-dimensional line, but if you get close enough, you can see that it has a circular dimension wrapped around its circumference. The extra dimensions in string theory are thought to be curled up in a similar way, but at a scale far smaller than anything we can currently probe. Now, these extra dimensions aren't just mathematical curiosities. They play a crucial role in determining the properties of the particles and forces in our universe. The shape and size of these extra dimensions determine the way the strings vibrate, and the way the strings vibrate determines the type of particles that exist. It's a bit like the shape of a musical instrument determining the types of sounds it can produce. And here's where the multiverse enters the picture. String theory suggests that there isn't just one way to curl up these extra dimensions. There are countless possibilities, each corresponding to a different universe with its own unique set of physical laws. This vast collection of possible universes is known as the string theory landscape. Imagine a vast mountain range, with each valley representing a different possible configuration of the extra dimensions. Each valley corresponds to a different universe with its own set of physical laws and its own unique properties. Our universe is just one of these valleys, one particular solution to the equations of string theory. But what lies beyond our valley? What other universes are out there in the string theory landscape? Are they similar to our own, or are they radically different, governed by entirely different laws of physics? And how could we ever hope to explore these other universes if they are hidden away in the depths of extra-dimensional space? This theory also suggests that there are multiple realities existing side by side. The concept of brains offers another mind-bending perspective. These are like membranes that can exist in higher dimensional space, and our universe could be confined to one of these brains. But what if there are other brains floating nearby, each hosting its own universe? These questions are at the forefront of modern physics, pushing the boundaries of our understanding and challenging our most basic assumptions about the nature of reality. While definitive proof remains elusive, the possibility of a multiverse arising from string theory and M-theory continues to fuel the imaginations of scientists and storytellers alike. So could these vibrating strings really be the key to unlocking the secrets of the multiverse? And what other hidden dimensions might be waiting to be discovered? But even if these vibrating strings really are the answer, if they do unlock a new dimension of understanding, we still face a daunting question. How do we even begin to organize this mind-boggling array of potential universes? Is there a way to make sense of this cosmic zoo? To classify the different types of multiverses that might exist? One physicist dared to try to bring order to this seemingly chaotic landscape. Imagine a scientist, driven by an insatiable curiosity and armed with a formidable intellect, setting out to map the uncharted territories of the multiverse. That scientist is Max Tegmark, a professor of physics at the Massachusetts Institute of Technology. Tegmark, a man known for his bold ideas and his willingness to challenge conventional wisdom, has proposed a hierarchy of multiverses, a classification system that attempts to categorize the different types of parallel worlds that might exist. Tegmark's multiverse classification system consists of 4 distinct levels, each more mind-bending than the last. These levels aren't just arbitrary groupings. They represent fundamentally different ways in which other universes could exist, ranging from regions of space that are simply too far away to see, to universes with entirely different physical laws. The first level, Level 1, is perhaps the easiest to grasp. It posits that our universe is infinite, or at least so large that it might as well be. If this is the case, then somewhere out there, beyond the reach of our telescopes, there must be regions of space that are virtually identical to our own. Think about it. If you have an infinite number of possibilities, then every possible arrangement of matter must occur, not just once, but infinitely many times. So, somewhere out there, there's another Earth, with another you, reading this very text, and another, stretching out to infinity. The catch is, these universes are so far away that we could never hope to reach them, or even see them. The expansion of the universe itself prevents light from these distant regions ever reaching us. Level 2 takes things up a notch. It suggests that other universes exist as separate bubble universes, each with its own unique set of physical laws and constants. Remember the theory of cosmic inflation, the idea that the early universe underwent a period of rapid expansion? Well, according to Level 2, this inflation may have spawned countless bubble universes, each with its own Big Bang and its own independent evolution. These bubble universes could have radically different properties than our own. The strength of gravity might be different, the mass of the electron might be different, or the number of spatial dimensions might be different. In some of these universes, life as we know it might be impossible. In others, entirely new forms of life might exist, forms that we can't even begin to imagine. Level 3 is where things get really strange, delving into the heart of quantum mechanics and the many worlds interpretation. This level proposes that every quantum measurement causes the universe to split into multiple parallel universes, each representing a different possible outcome. So every time you make a decision, every time a quantum event occurs, the universe branches, creating new realities that are distinct but equally real. In one universe, you choose coffee over tea. In another, you choose tea over coffee. In yet another, you spill your drink all over yourself. The possibilities are endless. Level 4, the most speculative and controversial of all, proposes that all possible mathematical structures exist as physical universes. This means that any universe that can be described by mathematics actually exists somewhere. It also means that universes with entirely different laws of physics, universes that are fundamentally different from our own, are not just possible, they are inevitable. It is all based on math. Imagine a universe made of Lego bricks, or a universe governed by the rules of a video game. According to Level 4, these universes, no matter how bizarre or outlandish, actually exist as physical realities. The implications of this are mind-boggling, suggesting that the universe is far more diverse and complex than we can possibly imagine. Tegmark's classification system is not without its critics. Some physicists argue that it is too speculative, that it ventures too far beyond the realm of testable science. Others question whether Level 4 even makes sense, arguing that mathematics is just a tool for describing reality, not a blueprint for creating it. Despite these criticisms, Tegmark's hierarchy provides a valuable framework for thinking about the multiverse, for organizing the different possibilities and exploring the implications of each level. It helps us to understand the different scales and types of parallel worlds that scientists have hypothesized, allowing us to begin to grapple with the sheer immensity and complexity of the multiverse concept. Each level represents an increasing departure from our everyday experience, pushing the boundaries of our understanding and forcing us to confront the profound questions about the nature of reality itself. Perhaps someday we'll find a way to peek behind the curtain and catch a glimpse of these other realities. But until then, the multiverse remains a tantalizing mystery, a cosmic puzzle that continues to challenge and inspire us. So, if we find ourselves adrift in this infinite sea of possibilities, bobbing along on our little bubble of a universe, the ultimate question looms large. Can we ever truly know if the multiverse is real? Can we ever gather concrete evidence, proof beyond a reasonable doubt, that other universes exist? It is the elephant in the room for any scientist brave enough to ponder such a grand idea. Imagine trying to prove the existence of a hidden room, one you can't directly enter. You might look for subtle clues, drafts coming from under the door, faint sounds filtering through the walls, or perhaps even a shadow flickering in the corner of your eye. In a similar way, scientists are searching for subtle clues, cosmic fingerprints, that might betray the presence of other universes. The challenge, however, is that these fingerprints may be incredibly faint, buried beneath layers of cosmic noise. But what are these fingerprints? What specific evidence could point towards the existence of the multiverse? One promising area of investigation lies in the cosmic microwave background, or CMB. This is the afterglow of the Big Bang, the faint radiation that permeates the entire universe. It is essentially a snapshot of the universe as it existed nearly 14 billion years ago, a baby picture of the cosmos. Now scientists have to find a way to look at that picture very, very closely. Think of the CMB as a vast canvas stretched across the sky, painted with subtle variations in temperature. These variations, these tiny hot and cold spots, represent the seeds of galaxies and other large-scale structures in the universe. By studying the patterns in the CMB, scientists can learn a great deal about the early universe, about its composition, its density, and its rate of expansion. But could these patterns also hold clues about the multiverse? That is what scientists have been struggling to find. Some theories suggest that collisions between bubble universes, those separate universes spawned from cosmic inflation, could leave detectable marks on the CMB. Imagine two bubbles bumping into each other, creating ripples in the fabric of space-time. These ripples, these cosmic collisions, could imprint themselves on the CMB, creating circular patterns or other distinctive features. Finding such patterns would be like finding a signature from another universe, a calling card from a distant reality. The signal would be so small, though it could be almost impossible to prove. Scientists are actively searching for these patterns, poring over data from telescopes and satellites, hoping to catch a glimpse of these inter-universal collisions. It is a daunting task, like searching for a needle in a cosmic haystack. The CMB is filled with noise, with foreground signals from our own galaxy and from other astronomical objects. Separating these signals from the faint signatures of other universes requires sophisticated techniques and painstaking analysis. Another potential source of evidence lies in particle physics experiments. Some multiverse theories predict the existence of extra dimensions, dimensions beyond the three we experience in our everyday lives. These extra dimensions, curled up at incredibly small scales, might influence the behavior of particles in our universe. What if particles could travel between universes? Imagine a particle accelerator smashing particles together at nearly the speed of light, recreating the conditions that existed in the early universe. These collisions could potentially reveal the existence of new particles, particles that interact with these extra dimensions, particles that might even travel into other universes. The Large Hadron Collider, or LHC, the world's largest and most powerful particle accelerator, is actively searching for such particles, hoping to uncover evidence of these hidden dimensions. It is a high-stakes game, a quest to unlock the fundamental secrets of the universe. One of the most daring ideas is that gravity could be leaking between universes. Some theoretical frameworks posit that gravity, unlike the other fundamental forces, might not be confined to our brain, that membrane in higher dimensional space that contains our universe. Instead, gravity might be able to propagate through the bulk, the higher dimensional space surrounding our brain, allowing it to interact with other brains, other universes. If this were the case, then we might be able to detect the effects of these other universes on our own. For example, the gravitational pull of another universe might subtly alter the motion of galaxies in our own universe. Or it might influence the expansion rate of the universe, causing it to accelerate faster than expected. Scientists are constantly refining their models and searching for new ways to test these theories. They are pushing the boundaries of our understanding, venturing into uncharted territories of the cosmos. The search for evidence of the multiverse is a challenging but ultimately rewarding endeavor. It forces us to question our assumptions about the nature of reality, to explore the limits of our knowledge, and to imagine the unimaginable. Are we up for the challenge? The quest for evidence is far from over, and the road ahead is filled with uncertainties. But the possibility of finding proof, of finally answering the question of whether we are alone in the cosmos, is enough to keep scientists searching, exploring, and pushing the boundaries of what we know and what we think is even possible. For within the cosmic fingerprint, within those subtle anomalies and unexpected patterns, might lie the key to unlocking the greatest mystery of all, with that mystery being the secrets to the multiverse. The quest to find another you, a cosmic doppelganger living out a different life in a parallel universe, may seem like the ultimate narcissistic pursuit. But behind the science fiction fantasy lies a question that has plagued philosophers and scientists for centuries. What exactly makes you, you? If infinite versions of yourself exist scattered across the multiverse, what defines your unique identity? Is it your physical body, your memories, your personality, or something more elusive? Prepare to dive into the very essence of self, to explore the boundaries of consciousness, and to grapple with the mind-bending implications of a multiverse teeming with alternate selves. Consider this. If every quantum decision, every fleeting moment of chance spawns a new universe, then there exists a reality where you made a different choice at a crucial crossroads in your life. Perhaps you pursued a different career, married a different person, or even decided to stay in a different city. In that universe, a slightly altered version of you is living out a life that diverges from your own at every turn. But is that other you still you? This question takes us to the heart of philosophical debates about personal identity. For centuries, thinkers like John Locke and David Hume have grappled with the nature of selfhood, searching for the essential ingredients that make us who we are. Locke, for example, argued that consciousness and memory are key to personal identity. He believed that we are essentially the sum of our experiences, and that our memories bind us to our past selves, creating a continuous sense of identity over time. But what happens when memories diverge? What if your alternate self in another universe has a completely different set of memories, shaped by different experiences? Would you still consider that person to be you? Or would they be a completely separate individual, merely sharing your physical appearance? Hume, on the other hand, questioned the very notion of a stable, enduring self. He argued that we are nothing more than a bundle of perceptions, a constantly shifting stream of thoughts, feelings, and sensations. There is no underlying self that remains constant over time. If Hume is right, then the idea of a unified, consistent identity across the multiverse might be an illusion. Each version of you, shaped by its unique set of experiences, would be a completely distinct individual, a fleeting collection of perceptions in a particular universe. But the plot thickens when we consider the role of genetics. Do we carry an immutable blueprint, a biological code that defines our core essence, regardless of the universe we inhabit? It's been said that we are all just genes trying to replicate. After all, our genes play a significant role in shaping our physical traits, our predispositions, and even some aspects of our personality. If your alternate self shares your genes, does that create a fundamental connection, a shared biological identity that transcends the boundaries of different universes? Perhaps the answer lies not in searching for a single, definitive answer, but in embracing the complexity and ambiguity of the question itself. The idea of alternate selves in a multiverse may force us to redefine what it means to be an individual, to recognize that identity is not a fixed, static entity, but a fluid, ever-evolving process. Consider, for instance, the case of identical twins raised in separate homes. They share the exact same genetic makeup, yet they often develop distinct personalities, interests, and life paths shaped by their unique environments and experiences. If even twins, sharing the same genes and originating from the same universe, can diverge so dramatically, what does that say about the potential for variation across the vast expanse of the multiverse? What would happen if one twin became a famous celebrity while the other became a monk? Would you say they are the same or completely different? The psychological implications of the multiverse are equally profound. What impact would it have on your sense of self if you knew that infinite versions of you exist, some living lives of unimaginable success and happiness, others mired in misery and despair? Would it inspire you to strive for greater heights, or would it lead to a sense of existential dread? A feeling that your own life is ultimately meaningless in the face of infinite possibilities. The question is so mind-numbing that many people avoid even thinking about it. Perhaps the key lies in focusing on the present moment, on appreciating the unique experiences and relationships that shape your own individual journey. After all, even if infinite versions of you exist, none of them are experiencing this exact moment, this specific combination of thoughts, feelings, and sensations. In that sense, your present experience is unique, irreplaceable, and infinitely precious. Imagine if you could somehow communicate with your alternate selves, exchange stories, learn from their successes and failures. What wisdom would you gain from those interactions? What new perspectives would you develop? Would it strengthen your sense of self, or would it shatter your understanding of who you are? What would happen if you learned that the other you had achieved all your dreams, while the other you had experienced your worst nightmares? It all sounds like a science fiction movie, but it makes one ponder. The concept of identity in the multiverse raises ethical questions as well. If you could somehow transfer your consciousness into the body of an alternate self, would you have the right to control their life, to make decisions that affect their future? Would you be essentially stealing their identity, or would you be merging with them, creating a new hybrid self? What makes them so different if you are one and the same? These are not just abstract philosophical questions. As technology advances, as we develop new ways to manipulate consciousness, to create artificial intelligence, and to explore the boundaries of reality, these questions may become increasingly relevant. The multiverse, whether it exists or not, forces us to confront the fundamental questions about what it means to be human, to be conscious, and to be unique. What would happen if an AI achieved consciousness and the multiverse came into play? The search for your alternate selves may ultimately lead you back to yourself, to a deeper appreciation of your own unique story, your own individual journey. It may remind you that even in the face of infinite possibilities, your life has meaning, your choices matter, and your existence is a precious gift. The possibilities appear limitless, but just as we begin to grasp the scope of what it means to exist as an individual, a new set of questions emerge, questions that challenge our fundamental understanding of ethics and responsibility in a potentially infinite landscape of selves. The possibilities appear limitless, but just as we begin to grasp the scope of what it means to exist as an individual, a new set of questions emerge, questions that challenge our fundamental understanding of ethics and responsibility in a potentially infinite landscape of selves. Imagine standing at a crossroads in your life, a pivotal moment where your future hinges on a single decision. Perhaps it is accepting a job offer in a faraway city, proposing to the person you love, or taking a leap of faith to pursue a lifelong dream. Now, consider that in another universe, you made a different choice. A choice that led you down a completely different path. What would that life look like? Who would you be? The mind reels at the sheer number of potential alternate realities. In one universe, you might be a world-renowned scientist, making groundbreaking discoveries that revolutionize our understanding of the cosmos. In another, you might be a struggling artist, pouring your heart and soul into creations that never quite find their audience. Perhaps you are married with a large family, living a life of quiet contentment in a small town. Or maybe you are a solo adventurer, traveling the world and seeking thrills in every corner of the globe. What if that missed connection at the coffee shop actually led to a whirlwind romance in another reality? What if that risky investment paid off handsomely, transforming you into a billionaire philanthropist in a parallel world? The implications are staggering. Every choice you have ever made, every opportunity you have seized or let slip away, has spawned a new universe, a new version of you, living out a different destiny. Think about the roads not taken, the paths you glimpsed but ultimately chose not to follow. That career change you considered but ultimately dismissed. That relationship you almost pursued but ultimately shied away from. That daring adventure you dreamed of but ultimately deemed too risky. In the multiverse, those possibilities are not just fantasies, they are realities, being lived out by other versions of you. One might ask, what about the dreams that never came to fruition? Are there realities where you are already living the life you dreamed of, achieving all your goals and experiencing unbridled joy? Perhaps the most unsettling question of all is this: what about the nightmares? Are there universes where you are struggling, suffering, and experiencing the darkest depths of human despair? The thought that another version of you might be enduring unimaginable pain is enough to send shivers down the spine. Consider the butterfly effect, that well-known concept from chaos theory, which states that a small change in initial conditions can have a dramatic impact on the outcome of a system. A butterfly flapping its wings in Brazil can, theoretically, set off a tornado in Texas. Now, imagine the butterfly effect playing out across the multiverse, with every quantum decision acting as a tiny flap of a butterfly's wings, creating ripples that spread across countless parallel realities. What if your alternate self made a single, seemingly insignificant decision differently, and that decision led to a chain of events that transformed their entire life? Perhaps they were involved in an accident that altered their perspective on the world, leading them to dedicate their life to helping others. Maybe they had a chance encounter with a mentor who recognized their hidden talents and guided them down a path of extraordinary success. Or perhaps they experienced a crushing loss that forced them to confront their own mortality and live each day to the fullest. The spectrum of lives your alternate selves might be leading is as vast and diverse as the universe itself. It is a landscape of infinite possibilities filled with both breathtaking beauty and unspeakable horror. But beyond the shock and awe, beyond the existential angst, lies a profound opportunity for self-reflection. By contemplating the lives of our alternate selves, we can gain a deeper understanding of our own choices, our own values, and our own potential. If you could glimpse the life of another you, what would you hope to see? Would you want to see a version of yourself who is happier, more successful, or more fulfilled? Or would you be content to see a version of yourself who is simply different, living a life that is equally valid and meaningful, even if it is not the life you would have chosen for yourself? Perhaps the greatest gift of the multiverse is the realization that there is no single correct way to live a life. There are countless paths to happiness, to fulfillment, to meaning, and each of those paths is worthy of exploration, even if only in the realm of imagination. And so as we stand at the edge of the infinite, peering into the landscape of lives, we cannot help but wonder about the ethical dimensions that may lie ahead. The question is, if other versions of you exist and are presented before you, do you bear any connection or responsibility to them? And so, as we stand at the edge of the infinite, peering into the landscape of lives, we cannot help but wonder about the ethical dimensions that may lie ahead. The question is, if other versions of you exist and are presented before you, do you bear any connection or responsibility to them? But let's step back for a moment, away from the dizzying prospects of infinite selves and infinite choices, and consider something even more fundamental, the very reason we're here to ponder these questions in the first place. Why is our universe, this particular bubble in the cosmic foam, so remarkably hospitable to life? It is a question that has puzzled scientists and philosophers for centuries. It's a mystery that strikes at the heart of our understanding of the cosmos. Why do the fundamental constants of nature, the speed of light, the strength of gravity, the mass of the electron, seem so exquisitely tuned to allow for the existence of stars, planets, and ultimately life itself? Imagine a dial with countless settings representing different values for these fundamental constants. If you were to turn that dial even slightly, even by a fraction of a percent, the consequences could be catastrophic. Stars might burn too quickly or not form at all. Atoms might not hold together. The universe might collapse in on itself or expand so rapidly that matter would never coalesce. It's as if the universe were a meticulously crafted machine, designed with incredible precision to support life. But who or what designed it? Was it a cosmic accident, a stroke of blind luck? Or is there a deeper explanation, a hidden mechanism at play? This conundrum is often referred to as the fine-tuning problem. The precise values of these constants seem incredibly improbable, like winning the cosmic lottery. What are the odds that a universe would arise with exactly the right conditions for life to flourish? Some physicists have suggested that there is a divine creator, a cosmic watchmaker who carefully set the dials to create a universe hospitable to humanity. Others have invoked the anthropic principle, a controversial idea that suggests the universe is the way it is, because if it were any different, we wouldn't be here to observe it. Think about it this way. If the universe were not fine-tuned for life, then there would be no observers to marvel at its existence. We are, by definition, the products of a universe that allows for our existence. It is like a drop of water in the ocean questioning why it is wet. Well, it is wet because it is in the ocean. The anthropic principle comes in different flavors. The weak anthropic principle simply states that our observations are necessarily biased by the conditions that allow for our existence. The strong anthropic principle goes further, suggesting that the universe must inevitably evolve in such a way as to allow for observers to arise. It's a bold claim, but one that has generated a great deal of debate. However, some find this explanation unsatisfying. It seems to imply that the universe is somehow rigged, that its sole purpose is to create us. It leaves open the question of why the universe would be designed in such a way. But what if there is a third explanation, a more elegant and compelling answer to the fine-tuning problem? What if the multiverse offers a solution? Perhaps our universe is not unique, but simply one of countless universes, each with its own set of physical laws and constants. In this vast multiverse, most universes would be sterile, devoid of stars, planets, and life. They would be cosmic wastelands, governed by laws that are incompatible with complexity. But in a tiny fraction of these universes, perhaps through sheer chance, the constants would be just right for life to arise. We, of course, would find ourselves in one of those rare, life-friendly universes. It's like a cosmic Darwinian selection, where only the fittest universes survive, the ones that are capable of producing observers. The rest are simply unseen, unobserved, and ultimately irrelevant. In other words, the multiverse provides a statistical explanation for the fine-tuning problem. It is not that our universe was designed for life, but rather that we happen to live in one of the few universes where life is possible. It's like finding yourself in a room filled with lottery tickets and discovering that you have won. You might marvel at your incredible luck, but the explanation is simply that there were enough tickets to guarantee that someone would win. But does our existence constitute evidence for a multitude of cosmic possibilities? Some physicists argue that the fine-tuning problem, combined with the existence of fundamental constants, points towards the existence of something grander and infinitely more complex. It is akin to seeing a footprint on a deserted island and deducing the presence of other humans, even without seeing them directly. What would it mean if we ultimately discovered that the multiverse is real, that our universe is just one of countless others, each with its own unique set of laws and constants? How would it change our understanding of our place in the cosmos? Would it diminish our sense of importance, or would it inspire us to explore the vast possibilities that lie beyond our own universe? Imagine a future where we can travel to other universes, witnessing firsthand the diverse array of physical laws and the exotic forms of life that might exist. It would be a scientific revolution of unimaginable proportions, transforming our understanding of the universe and our place within it. Is it possible that in some of these universes, the very laws of physics are so different that our current understanding of science would be completely irrelevant? What would that mean for our own pursuit of knowledge? What if in some of those universes, our own laws of physics are so different that our universe could collide with it? As it stands, the fine-tuning problem remains one of the most profound and perplexing mysteries in modern science. It forces us to confront the fundamental questions about the nature of reality, the origin of life, and our place in the cosmos. And whether the answer lies in a divine creator, the anthropic principle, or the multiverse, the quest to understand this mystery will undoubtedly continue to drive scientific discovery for generations to come. But what if these bubble universes, existing as brains in higher dimensions, interacted with our own? But what if these bubble universes, existing as brains in higher dimensions, interacted with our own? Could these seemingly isolated realities somehow breach the boundaries of their existence and collide, leaving an indelible mark on our cosmos? It's a question that has sent ripples of both excitement and trepidation through the scientific community. Imagine two colossal soap bubbles, each containing its own unique reality, drifting through the vast expanse of a cosmic bathtub. Now picture those bubbles colliding, their surfaces distorting, their contents intermingling. Could such a collision occur between our universe and another? The concept of brains, short for membranes, is central to this idea. In string theory and M-theory, brains are extended objects that can exist in higher dimensional space. Think of them as surfaces or sheets floating in a multi-dimensional ocean. Our universe, with all its galaxies, stars, and planets, could be confined to one of these brains. But what if there are other brains, other universes floating nearby? These brains, like rafts on a cosmic sea, may be separated by vast distances in the higher dimensions, distances that are beyond our ability to perceive directly. However, some theories suggest that these brains are not static, that they can move and interact with each other. Could two brains, each hosting its own universe, collide? The collision of two brain worlds would be an event of unimaginable proportions, a cosmic cataclysm that would dwarf even the most energetic events in our own universe. The energy released during such a collision would be immense, creating a burst of radiation and gravitational waves that would ripple through space-time. Such an event would almost certainly be catastrophic, but what if that has already happened? Could such a collision leave detectable marks on our cosmos? Some scientists believe that the answer is yes. They propose that a brain collision could leave subtle but distinct signatures in the cosmic microwave background, the afterglow of the Big Bang. Imagine the cosmic microwave background as a canvas depicting the dawn of time. If another universe crashed into ours, what kind of brushstroke would it leave behind? These signatures might take the form of circular patterns, temperature variations, or other anomalies that could not be explained by conventional cosmological models. Finding such evidence would be like discovering a fingerprint from another universe, a tangible sign that we are not alone in the multiverse. Scientists are actively searching for these signatures, poring over data from telescopes and satellites, hoping to catch a glimpse of a cosmic collision. It is a search that requires patience, precision, and a willingness to challenge our most basic assumptions about the nature of reality. But even if we never find direct evidence of a brain collision, the very possibility raises profound questions about the nature of our universe and its place in the multiverse. If our universe is not unique, if it is just one of countless brains floating in higher dimensional space, then what does that mean for our understanding of the laws of physics? Could the fundamental constants of nature be different in other brains? Could there be universes where gravity is stronger, where the speed of light is slower, or where entirely new forces are at play? It is a question that challenges our deepest assumptions about the fabric of reality. Moreover, the possibility of inter-universal contact raises ethical considerations that are almost too mind-boggling to contemplate. If we were to discover a way to communicate with another universe, what would we say? What would we share? Would we risk revealing our existence to a civilization that might be far more advanced than our own? Or would we remain silent, fearing the potential consequences of contact? What if that universe was inhabited by another version of you? The potential for physics beyond our known 3 spatial dimensions is one of the most exciting and challenging areas of research in modern physics. Scientists are exploring new mathematical models and conducting experiments to probe the nature of space-time, searching for evidence of extra dimensions and new forces. Imagine a world where the laws of physics are not fixed, but are instead a reflection of the underlying geometry of space-time. In such a world, the possibilities would be endless. The idea of brain worlds and cosmic impacts may seem like science fiction, but it is rooted in some of the most advanced theories in modern physics. It is a testament to the power of human imagination and the relentless pursuit of knowledge that drives scientific inquiry. As we continue to explore the mysteries of the universe, we may one day find evidence that our universe is not alone, that it is just one of many brains floating in a vast, multidimensional sea. And while the concept is challenging to test, the potential to expand our understanding of the cosmos makes this a path worth exploring. What, then, would be the testability of these theories? But what if these bubble universes existing as brains in higher dimensions interacted with our own? Could these seemingly isolated realities somehow breach the boundaries of their existence and collide, leaving an indelible mark on our cosmos? The potential to expand our understanding of the cosmos makes this a path worth exploring. But how do we know if we are on the right path? Is there a way to test a theory that involves realities beyond our own, when it might be impossible to travel to them? This is the testability dilemma, the major sticking point for many scientists when it comes to the multiverse. How can we scientifically validate a concept that, by its very nature, may be beyond our observational reach? Imagine trying to prove the existence of a country you can never visit, a place with different laws and even different physics. This isn't just a technical hurdle, it's a philosophical one. At the heart of the scientific method lies the principle of falsifiability. Coined by the philosopher Karl Popper, this principle states that a scientific theory must be able to be proven wrong. A theory that cannot be falsified, that cannot be tested through observation or experiment, is not considered scientific. It exists in the realm of speculation, not science. Think of it this way. If you claim that all swans are white, you can easily test this by looking for a black swan. If you find one, your theory is falsified. But what if you claim that invisible, undetectable unicorns exist on a planet orbiting a distant star? How could you ever prove that wrong? The claim, while perhaps imaginative, is not falsifiable and therefore not scientific. So, where does the multiverse stand in all of this? Many multiverse theories, especially those involving bubble universes or level 4 multiverses, seem to be inherently untestable. How can we observe another universe if it exists beyond the reach of our telescopes? How can we interact with a reality governed by different physical laws? This apparent lack of testability has led to considerable skepticism within the scientific community. Some critics argue that multiverse theories are not science at all, but rather a form of metaphysics, a philosophical exercise that has no basis in empirical evidence. They claim that physicists are wasting their time and resources pursuing ideas that are fundamentally unprovable. After all, what separates science from pure fantasy if we abandon the need for testable predictions? Consider the words of Wolfgang Pauli, a Nobel Prize-winning physicist known for his sharp wit and even sharper critiques. Pauli famously dismissed many speculative theories as not even wrong, meaning that they were so vague and ill-defined that they couldn't even be proven false. Some scientists might argue that many multiverse theories fall into this category, but proponents of the multiverse argue that the situation is not so bleak. They contend that even if we cannot directly observe other universes, we may be able to find indirect evidence, subtle clues that point towards their existence. It is like trying to detect a ghost through the effects it has on the physical world. Imagine a detective investigating a crime scene. They may not have witnessed the crime directly, but they can gather circumstantial evidence, fingerprints, footprints, bloodstains that point towards the identity of the perpetrator. Similarly, physicists are searching for circumstantial evidence that might betray the presence of other universes. What if the existence of other universes is the most plausible explanation for certain observed phenomena in our own universe? If we observe something that cannot be explained by any known physics, but which is predicted by a particular multiverse theory, could that be considered evidence, even if indirect? The challenge, of course, is to rule out all other possible explanations. Take, for example, the fine-tuning problem we discussed earlier. The fact that the fundamental constants of nature seem so exquisitely tuned for life is a puzzle that has baffled scientists for decades. While it is not proof, could this suggest something is affecting our universe from beyond? Some scientists believe that anomalies in the cosmic microwave background, the afterglow of the Big Bang, might provide evidence of collisions with other bubble universes. Others are searching for subtle deviations in the behavior of particles at the Large Hadron Collider, deviations that might be caused by the influence of extra dimensions. What if a scientist at CERN, while smashing particles together at near light speed, detected a particle that defies all known laws of physics? Would that be enough to convince the scientific community that the multiverse is real? Probably not. But it would certainly spark a great deal of interest and further investigation. The debate surrounding the testability of multiverse theories is a healthy and necessary one. It forces scientists to confront the limits of the scientific method, to question their assumptions, and to develop new and creative ways of testing their ideas. Perhaps the key lies in shifting our perspective, in recognizing that the traditional notion of testability may not be applicable to all scientific theories. Maybe the very definition of testability needs to evolve. What if the evidence for the multiverse is not a single definitive observation, but rather a convergence of evidence from multiple sources, a mosaic of clues that, when pieced together, paints a compelling picture of a vast and interconnected cosmos? Maybe the future of multiverse research lies not in proving its existence, but in exploring its implications, in developing models that make testable predictions about the properties of our own universe. The scientific community has remained strong in its skepticism, but if we find the keys to unlock this mysterious realm, we might stumble upon the ability to travel between worlds. As it stands, the testability dilemma remains a major challenge for multiverse theories, but it is not an insurmountable one. Scientists are continuing to push the boundaries of what we know and what we think is possible, developing new and innovative ways of exploring the cosmos. Perhaps one day, we will find a way to bridge the gap between theory and experiment, to finally answer the question of whether we are alone in the multiverse. But even if we do manage to find evidence, what contraptions and impossible portals will we need to travel between worlds? Even if we find the keys to unlock this mysterious realm and prove the existence of a multiverse, what contraptions and impossible gateways would we need to travel between worlds? Science fiction has long captivated our imaginations with visions of portals, shimmering doorways that lead to alternate realities. From the rabbit hole in Alice in Wonderland to the Stargate in, well, Stargate, the idea of instantaneous travel to another dimension is a recurring trope in our collective consciousness. But how much of this is pure fantasy, and how much is grounded in actual physics? Consider the wormhole, that staple of science fiction that allows interstellar and even interdimensional travel. The concept springs from Einstein's theory of general relativity, which describes gravity not as a force, but as a curvature of space-time. Imagine space-time as a fabric, and massive objects like stars and black holes create dents in that fabric. A wormhole, theoretically, is a tunnel that connects two distant points in space-time, a shortcut through the cosmos. Think of it like folding a piece of paper in half. 2 points that were once far apart are now touching. A wormhole is essentially a cosmic shortcut, allowing you to bypass the vast distances of space and time. But there is, of course, a catch, or rather, many catches. Einstein's equations do allow for the possibility of wormholes, but they also suggest that such structures would be incredibly unstable, collapsing almost as soon as they formed. To keep a wormhole open, you would need something with negative mass density, something that creates anti-gravity. Physicists call this exotic matter. What is exotic matter? It is matter with properties that defy our everyday experience. It would have to have a negative mass density, which means that instead of being attracted to gravity, it would be repelled. It would need to violate various energy conditions, fundamental principles that govern the behavior of matter and energy. Finding exotic matter has been the subject of multiple science fiction stories. Is exotic matter even possible? Scientists are not sure. Some theoretical models suggest that it might exist, perhaps in the form of quantum fluctuations or hypothetical particles. But so far no one has ever observed exotic matter, and even if we did, producing enough of it to stabilize a wormhole would require an amount of energy that is far beyond our current capabilities. One estimate suggests that stabilizing a wormhole large enough for a human to pass through would require the energy equivalent to the mass of Jupiter converted entirely into exotic matter. Beyond the need for exotic matter, there are other challenges to wormhole travel. The intense gravitational forces near a wormhole would likely rip apart any object that tried to pass through it, a process delicately referred to as spaghettification. The radiation environment inside a wormhole would be incredibly harsh, potentially frying any unfortunate traveler. And even if you could survive the journey, there is no guarantee that you would end up where you intended to go. Wormholes might lead to different points in time, different universes, or simply dead ends. What about using portals to other universes? The physics is even more speculative if that is possible. If we cannot even travel across our own universe, what hope do we have of jumping between universes? Some theories suggest that certain black holes might act as gateways to other realities, but these are highly speculative ideas, bordering on science fantasy. What would happen to a body jumping through that gateway in the first place? Consider the immense energy required to create and maintain a stable portal between universes. You would need to somehow manipulate the fabric of space-time, creating a tear between two different realities. This would require a level of energy that is far beyond anything we can currently imagine. And even if you could create a portal, there is no guarantee that it would lead to a hospitable universe. You might end up in a reality where the laws of physics are completely different, where matter cannot exist, or where time runs backwards. So, while science fiction often depicts portals and wormholes as convenient shortcuts through the multiverse, the reality is far more complex and challenging. The theoretical physics behind these concepts is still in its infancy, and the technological hurdles are immense. But that doesn't mean that we should give up on the dream of interdimensional travel. After all, many of the technologies we take for granted today were once considered to be science fiction. Perhaps, with enough ingenuity and perseverance, we may one day find a way to traverse the vast distances of the multiverse, to explore new realities and encounter other versions of ourselves. For now, these gateways exist only in our imagination, but storytelling reflects our deep-seated curiosity about other realities. Even with the theoretical pathways laid before us, the immense energy and exotic matter required may be beyond our reach. For now, such gateways exist only in the realm of theoretical speculation, so why do we find ourselves so drawn to these ideas? Why does the notion of parallel worlds and alternate selves continue to resonate so powerfully within the human imagination? The answer perhaps lies not in physics, but in the enduring power of storytelling. From ancient myths whispered around crackling fires to modern blockbuster films projected on towering screens, the concept of the multiverse has captivated audiences for millennia. But what exactly is it about this idea that speaks to something so fundamental within us? Think back to the earliest tales ever told. Myths and legends from cultures across the globe are often filled with stories of hidden realms, spirit worlds, and journeys to the underworld. The ancient Greeks had their Hades, the Celts had their otherworld, and countless indigenous cultures have their own versions of alternate realities that exist alongside our own. While these stories weren't necessarily based on scientific theories, they served as crucial expressions of our innate curiosity about the unknown. They were imaginative explorations of possibilities, born from our deep-seated desire to understand our place in the universe. What if there's more than meets the eye? What if the reality we perceive is just one facet of a much larger, more complex cosmic structure? Consider the Epic of Gilgamesh, one of the oldest known works of literature. This ancient Babylonian tale tells the story of a king's quest for immortality, a journey that takes him to the edges of the world and beyond. While not explicitly a multiverse story, it explores the themes of alternate realities, the limitations of human existence, and the search for meaning in a vast and mysterious cosmos. Perhaps these are elements that are inherent to the human condition. Fast forward a few thousand years, and we see the emergence of science fiction as a distinct genre. Writers like Jules Verne and H.G. Wells began to explore the possibilities of technology and scientific discovery, creating fantastical worlds that challenged the boundaries of what was considered possible. But it was perhaps writers like Lewis Carroll and later Jorge Luis Borges who started to more fully explore the idea of alternate realities and parallel selves. Carroll's Alice's Adventures in Wonderland, for example, which was published in 1865, is not just a children's story but a profound exploration of the nature of reality. Alice's journey down the rabbit hole takes her to a world where the laws of logic and physics are turned upside down, a world where anything is possible. And in a way, this is how the scientific community viewed the multiverse. What if this world had its own rules and laws that were separate from ours? Consider also the works of Jorge Luis Borges, an Argentinian writer whose short stories are filled with labyrinthine libraries, infinite mirrors, and branching paths that lead to alternate realities. Borges's stories are not just about science fiction, they are about the nature of reality, the power of imagination, and the human condition. How could you get out of this library of infinite possibilities? Moving into the 20th and 21st centuries, we see the multiverse explode into popular culture, appearing in countless books, comics, television shows, and movies. Comic books in particular played a pivotal role in popularizing the concept of the multiverse. Publishers like Marvel and DC Comics introduced the idea of alternate universes to explain continuity errors, create new storylines, and explore different versions of beloved characters. Imagine a world where Superman is evil, or where Spider-Man is a woman, or where Batman is a vampire. Comic books have explored all of these possibilities and more, creating a vast and ever-expanding multiverse of alternate realities. And it all started with one comic book writer who wanted to tell a story that was just a little bit different. Television shows like The Twilight Zone and Star Trek also played a significant role in bringing the multiverse to a wider audience. The Twilight Zone, in particular, was known for its thought-provoking stories that often explored themes of alternate realities, parallel universes, and the fragility of human existence. What if you woke up one day and found yourself in a world where everything was just slightly different? More recently, movies like Doctor Strange and the Multiverse of Madness and Everything Everywhere All at Once have taken the multiverse concept to new heights of visual spectacle and emotional depth. These films explore the idea of infinite possibilities, the consequences of our choices, and the power of human connection in the face of cosmic absurdity. What happens if a character starts jumping between universes? What is perhaps most fascinating about the multiverse in popular culture is the recurring themes and tropes that emerge across different stories. The idea of the doppelganger, the alternate self who is both familiar and alien, is a common trope, as is the notion of parallel worlds that are both similar to and different from our own. Why are we so drawn to these ideas? What do they tell us about ourselves? Perhaps these stories reflect our deep-seated desire to explore the roads not taken, to glimpse what might have been if we had made different choices in our lives. Perhaps they offer us a sense of comfort, a reassurance that even if we make mistakes, there are other versions of ourselves out there who are living better lives. Or perhaps they simply provide us with a sense of wonder, a reminder that the universe is far more vast and mysterious than we can possibly imagine. Whatever the reason, the multiverse has clearly struck a chord with the human imagination. It is an idea that allows us to explore the boundaries of reality, to challenge our assumptions about the nature of existence, and to contemplate the infinite possibilities that lie beyond our own universe. And as we continue to grapple with the scientific and philosophical implications of the multiverse, we will undoubtedly continue to see it reflected in our stories, our myths, and our dreams. What mind-bending paradoxes might arise from boundless parallel realities? Even with these scientific paths laid before us, our deep-seated curiosity about other realities has always reflected into storytelling. But stories often have a problem of paradoxes. If we are to take all of these ideas that have been suggested by the greatest minds in human history, then what happens to logic? So let's consider the thought that if the multiverse is truly infinite, and if we take all of it seriously, then what does that mean for us? What mind-bending paradoxes might arise from boundless parallel realities? Does the very idea of infinity break down when applied to something as personal as our own existence? Imagine a universe where every single possibility is realized, not just once, but an infinite number of times. This means that not only are there countless versions of you living out different lives, but there are also countless versions of you doing things that seem utterly impossible. Are you ready to question the very nature of reality itself? Let's take a seemingly simple action, for example, and imagine you are raising your hand. In one universe, you raise your right hand. In another, your left. Seems logical. But in the infinite expanse of the multiverse, does this mean there are also universes where you levitate your hand without any physical support? Universes where your hand transforms into a flock of birds that soar into the sky? Universes where your hand spontaneously combusts in a burst of blue flame? If every possibility is realized, no matter how improbable or absurd, then these scenarios must exist somewhere. This leads us to the paradox of the impossible self. If there are infinite versions of you, including those capable of performing impossible feats, then what exactly defines your limitations? What distinguishes the possible you from the impossible you? Does the very concept of limitation even hold meaning in an infinite multiverse? Perhaps this gets at the very essence of the question of our being. Consider the implications for free will. If every possible action is predetermined in one universe or another, then do we truly have the freedom to choose our own destiny, Are we merely puppets dancing on the strings of cosmic probability, our actions predetermined by the infinite tapestry of the multiverse? It would seem as though this cancels any sense of free will and that there is no amount of possibility that would change our destinies. The philosopher David Lewis grappled with similar questions in his work on modal realism, the idea that all possible worlds are equally real. Lewis argued that when we talk about possibilities, we are not just imagining them. We are referring to actual existing worlds where those possibilities are realized. But if all possible worlds are real, then does that mean that we are simply living out one predetermined path among an infinite number of others? The mathematician Georg Cantor revolutionized our understanding of infinity in the late 19th century when he demonstrated that there are different sizes of infinity. Some infinities are larger than others. The infinity of whole numbers, for example, is smaller than the infinity of real numbers. So could we apply this concept to the multiverse? Are there different levels of infinity when it comes to alternate selves? Could there be infinities of you living ordinary lives and then a separate, larger infinity of you doing the impossible? What about the ethical implications? If there are infinite versions of you, some of whom are committing heinous acts, do you bear any responsibility for their actions? Are you somehow connected to them, even if you are separated by vast distances and different realities? If there is a version of you that saves 1,000,000 lives, do you feel good for that universe? Perhaps these are questions that we can never fully answer, paradoxes that will forever haunt our understanding of the multiverse. But it is in grappling with these paradoxes that we push the boundaries of our knowledge, that we challenge our assumptions, and that we glimpse the profound mysteries that lie at the heart of reality. But as we continue our exploration, we must also question how we make predictions and determine probabilities in the multiverse. But as we continue our exploration, we must also question how we make predictions and determine probabilities in the multiverse. If everything happens, standard probability seems to break down. This is the measure problem. In an infinite multiverse, how do we know when to cross the street? Would it not be that every second your body is in danger but would exist again in another reality again and again? Is this all just a moot point? As scientists wrestle with these mind-bending questions, another possibility emerges, a concept that blurs the line between science and science fiction. Could our perceived reality be a sophisticated computer simulation? Imagine a future so technologically advanced that entire universes can be created and run within a supercomputer. It is a concept popularized by films like The Matrix, but it has also been seriously considered by some of the brightest minds in science and technology. If such simulations are possible, and if they are sufficiently advanced, how could we ever know whether we are living in one? The simulation hypothesis, championed by philosopher Nick Bostrom, argues that one of three possibilities must be true. First, that humans will almost certainly go extinct before reaching a point where they can create such simulations. Second, that even if we reach that point, we will likely choose not to run these simulations, perhaps due to ethical concerns or resource constraints. Or third, that we are almost certainly living in a computer simulation. Bostrom's argument rests on the assumption that technologically advanced civilizations would have the ability to create vast numbers of simulated realities, each populated by conscious beings. If this is the case, then the number of simulated minds would far outnumber the number of real minds. Therefore, it is more likely that we are one of the simulated minds, rather than one of the original, real minds. Does this not create the philosophical problem of what is real in the first place? Think about it. If you could create a simulation so realistic that the simulated beings within it were completely unaware of their artificial nature, would that not be a profound ethical responsibility? Would you have the right to control their lives, to experiment with their realities, or even to delete them altogether? The similarities between the simulation hypothesis and multiverse theories are striking. Both concepts propose that our perceived reality is not the only reality, that there are other levels of existence beyond our immediate perception. Both challenge our assumptions about the nature of consciousness and the limits of what is possible. But that brings us to the question, which is most believable? In the multiverse, other universes exist as physical realities, governed by their own sets of physical laws. In the simulation hypothesis, our universe is a virtual reality, a computer program running on a supercomputer. Both concepts raise profound questions about our place in the cosmos and the nature of our existence. If our universe is just a simulation, who are the programmers? What are their motivations? And what happens when the simulation ends? Some scientists have even suggested that the universe itself might be a giant computer, processing information and generating reality through a series of computational processes. This idea, known as digital physics, proposes that the fundamental laws of physics are ultimately mathematical algorithms, and that the universe is essentially a vast, self-executing computer program. But how could we ever tell if we are living in a simulation? Are there glitches in the matrix? Subtle anomalies that might betray the artificial nature of our reality? Some physicists have suggested looking for limitations in the resolution of space-time, for evidence that our universe is pixelated at the smallest scales. If space and time are continuous, there is no limit to how finely they can be divided. If they are discrete, there is a fundamental unit of size, like the pixels on a computer screen. Perhaps one day, someone will create the ultimate code. Others have proposed searching for patterns in the cosmic microwave background, the afterglow of the Big Bang, that might reveal the handiwork of the simulators. If the universe was created by an outside intelligence, is there a hidden message for us? Consider the possibility that the laws of physics themselves are not fundamental, but rather are simply the rules of the simulation. The speed of light, the force of gravity, the mass of the electron, perhaps these are not immutable constants, but rather parameters that can be adjusted or altered by the programmers. What happens if the game programmers tweak gravity to have a more exciting game? Perhaps the ultimate test of the simulation hypothesis would be to find a way to break out of the simulation, to somehow transcend the limitations of our artificial reality. But how could we ever hope to achieve such a feat? What would it even mean to escape from a computer program? Maybe the answer lies within the human mind. The simulation hypothesis and multiverse theories are not mutually exclusive. It is possible that our universe is both a simulation and part of a larger multiverse. Perhaps there are countless simulated universes nested within countless physical universes, a never-ending hierarchy of realities. The question is then, where does it end? The simulation hypothesis and the multiverse both force us to confront the question, is our reality what it seems? Are we living in a genuine physical universe, or are we merely characters in a cosmic drama, our lives playing out according to someone else's script? These are questions that challenge our deepest assumptions about the nature of existence and the limits of our knowledge. But as we ponder these possibilities, we find ourselves wondering about something even more fundamental. What are the moral implications, if it's true? Even contemplating the infinite, however, brings us face to face with ourselves, or perhaps more accurately, ourselves. The simulation hypothesis and the multiverse are ideas that test the very limits of what we know and challenge us to consider the unthinkable. We wonder if we are living in a genuine physical universe, or are we merely characters in a cosmic play, our lives unfolding according to someone else's script. Now that we have explored the mind-bending nature of these possible realities, what moral implications are left to be uncovered? What if we are not alone even among ourselves, and what responsibilities do we have in a universe that has infinite possibilities? If other versions of you exist, scattered across the vast expanse of the multiverse, do you bear any connection, any responsibility to them? It is a question that cuts to the very heart of ethics. forcing us to grapple with concepts of right and wrong, not just in our own universe, but across an infinite spectrum of realities. What do you owe to someone who is essentially you, yet living a completely different life, shaped by different circumstances and different choices? Imagine for a moment that you have the ability to communicate with an alternate version of yourself in another universe. This other you has made vastly different life choices, leading them down a path that is both intriguing and perhaps unsettling. They might be living a life of unimaginable success and happiness, having achieved all of your dreams and desires. Or conversely, they might be mired in misery and despair, struggling with challenges and hardships that you can scarcely imagine. Do you feel any sense of obligation to help them, to offer them guidance, or to share your own experiences? Consider the ethical implications of intervention. If you could somehow alter the course of your alternate self's life, would you have the right to do so? Would it be ethical to interfere with their free will, to impose your own values and beliefs upon them? Or would it be more responsible to simply observe, to learn from their experiences, and to allow them to chart their own course, even if that course leads to suffering? What if interaction were not just possible, but commonplace? Suppose gateways between universes existed and travel became as easy as catching a bus. How would society change if it was aware that versions of themselves existed in every reality? The potential for exploitation and abuse is immense. Imagine unscrupulous individuals seeking to take advantage of their alternate selves in other universes, stealing their resources, exploiting their talents, or even enslaving them for personal gain. It is a disturbing scenario, but one that we must consider if we are to grapple with the ethical implications of the multiverse. Imagine, too, the potential for conflict. If different universes were to come into contact, with competing interests and conflicting ideologies, could that lead to inter-universal war? Could different versions of ourselves, driven by greed, ambition, or simply a desire for survival, engage in a cosmic battle for dominance? The stakes would be unimaginably high, with the fate of entire universes hanging in the balance. What about the concept of accountability? If an alternate version of you commits a crime in another universe, do you bear any responsibility for their actions? Could you be held liable for their transgressions even if you had no knowledge of their existence? It is a legal and ethical minefield, one that would challenge our most fundamental notions of justice and fairness. Consider the implications for personal responsibility. If you know that every choice you make spawns a new universe with a new version of you living out that alternate reality, does that change the way you make decisions? Does it make you more cautious, more deliberate, or more reckless? Do you feel a greater sense of responsibility for the consequences of your actions, knowing that those consequences will ripple across an infinite number of realities? If not, why does it matter what we do at all? One might argue that in an infinite multiverse, the actions of any one individual are ultimately insignificant. The vastness of the cosmic landscape renders our choices meaningless, our efforts futile. But perhaps the opposite is true. Perhaps it is precisely because of the infinity of the multiverse that our choices matter so much. Every act of kindness, every act of compassion, every act of courage has the potential to ripple across countless realities, creating a wave of positive change that resonates throughout the cosmos. What kind of effect would that universe have on our own? What if a universe with no poverty had an impact on our own universe or vice versa? How would this affect humanity? The ethical landscape of the multiverse is vast and uncharted, filled with complex questions and unsettling possibilities. As we continue to explore the mysteries of the cosmos, we must also grapple with the moral implications of our discoveries. The existence of alternate selves may force us to redefine what it means to be human, to be responsible, and to be ethical in a universe that is far more complex and interconnected than we ever imagined. So what experiments could be done to find out more about the multiverse? What discoveries still lie ahead? The search for these answers and the meaning behind it all continues, for we still have so much more to explore. If infinite versions of ourselves are living out every conceivable possibility across the multiverse, can we really say anything is truly impossible? If every quantum event spawns a new reality, where does that leave the concept of chance? How do you even begin to calculate the odds when literally anything, no matter how improbable, happens somewhere? The challenge is so significant that physicists have given it a name, the measure problem. It's a theoretical hurdle that strikes at the heart of many multiverse models, forcing us to confront the limitations of our understanding of probability and prediction in an infinite space. Imagine trying to predict the outcome of a coin flip, not just once, but an infinite number of times across an infinite number of universes. In some universes, the coin will land heads. In others, it will land tails. But what if there are also universes where the coin stands on its edge, or transforms into a miniature black hole, or spontaneously bursts into flames? If every possibility is realized, then the traditional rules of probability simply break down. How do you assign a meaningful statistical weight to any particular outcome when everything is happening somewhere, an infinite number of times? Consider the lottery. The odds of winning a multi-million-dollar jackpot are astronomical, something like 1 in 300 million. But in an infinite multiverse, someone wins the lottery in every possible draw, not just in our universe, but in countless others. So, does that make winning the lottery inevitable? Does it diminish the significance of winning in our own universe? Does it mean the odds we calculate are simply a comforting illusion? Think of it like this. If you were to throw a dart at a dartboard that stretched out to infinity, you would eventually hit every possible point on the board, not just once, but an infinite number of times. So what does it mean to aim? What does it mean to try to hit a specific target when every point is destined to be hit eventually? It almost makes you question even the day-to-day decisions that you make. The measure problem arises because in an infinite multiverse, the number of universes where something happens is always infinite, and the number of universes where it doesn't happen is also infinite. So, how do you compare two infinities? How do you determine which infinity is bigger or more likely? This is where things get mathematically tricky, and where different multiverse models run into serious difficulties. Some physicists have proposed using different measures to assign probabilities in the multiverse. A measure is essentially a way of weighting different universes, of saying that some universes are more numerous or more important than others. But choosing the right measure is a highly contentious issue, and different choices can lead to wildly different predictions. It causes scientists to question what they may know to be true in the first place. One popular approach is to use the volume of space-time as a measure. This suggests that universes with larger volumes of space-time are more numerous and therefore more likely. But this measure can lead to paradoxical results, such as the prediction that we should expect to find ourselves in universes that are on the verge of collapse, as those are the universes with the largest volumes of space-time. Another approach is to use the number of observers as a measure, arguing that universes with more observers are more numerous. But this raises thorny questions about what constitutes an observer and how to count them. Do we count only human beings, or do we include animals, artificial intelligences, or even hypothetical alien civilizations? Perhaps the most unsettling implication of the measure problem is that it may render many predictions about the multiverse meaningless. If we cannot assign meaningful probabilities to different outcomes, then what is the point of even considering the multiverse in the first place? Are we simply engaging in a philosophical thought experiment with no basis in reality? Does it make the math useless and our efforts futile? Some physicists have suggested that the measure problem is not a bug, but a feature of the multiverse. Perhaps the fact that we cannot make definitive predictions about the multiverse is telling us something profound about the nature of reality, about the limits of our knowledge, and about the inherent uncertainty of the cosmos. What if the measure problem is a sign that our current understanding of physics is incomplete, that we are missing some crucial piece of the puzzle that would allow us to make sense of the multiverse. Perhaps a deeper understanding of quantum gravity, the theory that seeks to reconcile general relativity with quantum mechanics, will provide the key to solving the measure problem. After all, you wouldn't build a house without laying the foundation first, right? The measure problem is a challenge that forces us to confront the very foundations of our scientific understanding, a challenge that may ultimately lead to a revolution in our understanding of the universe and our place within it. It almost gives you a headache just thinking about it. What else do we not know? But as scientists wrestle with these mind-bending questions, another possibility emerges, a concept that blurs the line between science and science fiction. Could our perceived reality be a sophisticated computer simulation? If standard probability falters amidst a sea of infinite possibilities, can the observer be the key to shaping the very fabric of reality? Could consciousness, that elusive spark of awareness, be more than just a byproduct of complex neural networks? Some interpretations of quantum mechanics dare to suggest that the act of observation itself plays a fundamental role in collapsing the wave function, in determining which reality becomes manifest. It is a notion that has tantalized physicists and philosophers for decades, blurring the lines between the objective world and the subjective experience. Imagine a quantum experiment designed to probe the behavior of a single photon, a particle of light. Before the measurement is made, the photon exists in a superposition of multiple states, a cloud of possibilities. But the moment a detector is switched on, the moment an observation is made, the photon chooses a definite state, a specific location or polarization. But why? What is it about the act of observation that forces the photon to make a choice? Some physicists, inspired by the Copenhagen interpretation of quantum mechanics, have argued that consciousness is the missing ingredient. They propose that it is the conscious observer, the human mind, that ultimately collapses the wave function, bringing reality into being. It is a controversial idea, one that has been met with both enthusiasm and skepticism. Is it possible that all of reality is a mental projection of sorts? This interpretation suggests that without an observer, the universe would exist in a state of pure potentiality, a realm of unformed possibilities. It is only through the act of conscious observation that the universe takes shape, that reality becomes definite. It is as if the universe is waiting for us to look at it, to bring it into existence. Consider the double-slit experiment, one of the most iconic and mind-bending experiments in quantum mechanics. In this experiment, particles such as electrons are fired one at a time towards a screen with two slits in it. What would happen if these particles actually acted as a wave as well as a particle? When no one is watching, the electrons pass through both slits simultaneously, creating an interference pattern on the screen, a pattern that is characteristic of waves. But when scientists try to observe which slit the electron passes through, the interference pattern disappears, and the electrons behave like particles, passing through only one slit or the other. The very act of observation seems to change the behavior of the electrons, forcing them to choose between being a wave and being a particle. The implications of this experiment are profound. It suggests that reality is not fixed, but rather is influenced by the act of observation. The observer is not just a passive bystander, but an active participant in shaping the universe. The scientific community has pondered the meaning behind this since its conception, and scientists continue to discover new ways to approach the experiment. Sir Roger Penrose, the esteemed mathematical physicist, has proposed that consciousness is linked to quantum processes occurring within the microtubules of brain cells. Microtubules are tiny cylindrical structures that play a crucial role in cell structure and function. Penrose argues that these microtubules are capable of supporting quantum superpositions, and that these quantum processes are somehow connected to our conscious experience. It is a bold claim, one that is still highly speculative, but it highlights the growing interest in the relationship between quantum mechanics and consciousness. How can one prove such a bold statement in the first place? Perhaps it is that questions like this are what make people seek out new scientific endeavors. What if the act of observation doesn't just collapse the wave function, but also triggers the splitting of universes, as proposed by the many worlds interpretation? In this view, every quantum measurement creates a new universe, each representing a different possible outcome. Consciousness, in this context, could be seen as the mechanism that selects which universe we experience, which reality becomes our own. This merges the many worlds interpretation with the concept of consciousness. Are you in a reality because you are conscious? This is just another point that needs discussion and could lead one to more conclusions. This raises profound questions about the nature of free will and the limits of our control over reality. If our consciousness is constantly selecting which universe we inhabit, can we consciously choose to jump to a more desirable reality? Can we actively shape our own destiny, not just within our own universe, but across the vast expanse of the multiverse? What does any of that truly mean? The intersections of quantum mechanics, consciousness, and the multiverse are some of the most fascinating and controversial areas of modern science. They force us to confront the deepest mysteries of existence, to question our assumptions about the nature of reality, and to grapple with the relationship between mind and matter. And maybe, just maybe, to realize that our conscious minds may have an even more integral role to play. As we push the boundaries of physics, however, there is always the possibility that the multiverse is far too complex. But even as we ponder the implications of our consciousness and the role it may play, a nagging question remains. In our quest to understand the universe, have we perhaps overcomplicated things? Are we chasing shadows in the dark, lured by the allure of the infinite when a simpler explanation might suffice? It is time to invoke Occam's razor, that venerable principle of scientific thinking that has guided countless discoveries for centuries. Named after the 14th century English friar and philosopher William of Ockham, Occam's razor is a principle of parsimony, a preference for simplicity. It suggests that among competing hypotheses, the one with the fewest assumptions should be selected. In other words, the simplest explanation is usually the best. The core idea is if you have two ideas that give you the same answer, you should pick the one that is the simplest. Think of it like this. You hear hoofbeats in the distance. Are you more likely to be hearing a horse or a zebra? While zebras do exist, it's far more probable that you are hearing a horse. The same logic applies to scientific theories. If two theories can explain the same phenomenon, the one that requires fewer extra assumptions is generally considered more plausible. Now let's apply this principle to the multiverse. Is invoking an infinite number of unobservable universes truly the simplest explanation for the mysteries of the cosmos? Or is it an extravagant theoretical leap, a solution that creates more problems than it solves? It is almost as if you are looking for a zebra when you should be looking for a horse. Consider the fine-tuning problem, that perplexing puzzle of why the fundamental constants of nature seem so perfectly tuned for life. We discussed how the multiverse offers one possible explanation. Perhaps countless universes exist, each with its own set of physical laws, and we simply inhabit one where conditions are right. But is the multiverse the simplest explanation for this fine-tuning? Some scientists argue that it is not. They contend that there may be other, more parsimonious explanations, such as the existence of a yet undiscovered physical principle that dictates the values of the fundamental constants. What if, for example, we discover a deeper theory that explains why the constants must have the values they do? A theory that eliminates the need for a vast ensemble of universes. That would certainly be a simpler and more elegant explanation than invoking the multiverse. The question then becomes, how can a complex universe have such simple laws? Or consider the mysteries of quantum mechanics. The many worlds. Interpretation proposes that every quantum measurement causes the universe to split into multiple parallel realities. While this interpretation elegantly avoids the problem of wave function collapse, it does so at the cost of introducing an infinite number of unobservable universes. Is there a simpler way to interpret quantum mechanics? Some physicists believe that there is. They argue that alternative interpretations such as pilot wave theory or objective collapse theories can explain the observed phenomena without resorting to the multiverse. These theories may be more complex in some ways, but they avoid the radical assumption of an infinite number of parallel realities. So which reality should we even invest in at all? The debate over Occam's razor and the multiverse is not just about aesthetics. It is about the very nature of scientific inquiry. Science is, at its core, about finding the simplest and most accurate descriptions of the natural world. It is about building models that make testable predictions and that can be verified through observation and experiment. If it cannot be tested, what is it for? Invoking an infinite number of unobservable universes may seem like a convenient way to explain away certain mysteries, but it also runs the risk of abandoning the core principles of science. It is crucial to constantly evaluate the trade-offs between explanatory power and theoretical simplicity. Is the added complexity of the multiverse truly necessary to explain the observed phenomena, or is it an unnecessary extravagance? The history of science is filled with examples of theories that were once considered elegant and parsimonious, but were later replaced by simpler and more accurate explanations. Ptolemy's geocentric model of the universe, with its intricate system of epicycles, was eventually supplanted by Copernicus's heliocentric model, which placed the Sun at the center of the solar system. The Ptolemy view was the accepted truth for almost 1,500 years. Einstein's theory of general relativity, with its elegant description of gravity as a curvature of space-time, replaced Newton's law of universal gravitation, which treated gravity as a force acting at a distance. Sometimes the older ideas have proven to work even better than the newer ones. It is a constant process of refinement, of striving to find the simplest and most accurate descriptions of the world around us. Does the multiverse meet those criteria? That is the question that scientists are grappling with today. Perhaps the ultimate answer lies in finding a way to test the multiverse, to gather empirical evidence that can either support or refute its existence. But until then, we must remain open to all possibilities, while also adhering to the principles of scientific rigor. And even if the multiverse turns out to be the correct explanation, we must be prepared to abandon it if a simpler and more accurate theory emerges. The quest for simplicity is not just a matter of intellectual elegance, it is a matter of scientific integrity. It is about striving to find the truth, even if that truth is more complex and unsettling than we ever imagined, because even if it feels like there are a lot of hurdles on the road ahead, there are new ones being constructed every step of the way. For now, the debate continues, and the question remains: is the multiverse a necessary complexity or an extravagant theoretical leap? Only time, and perhaps a few ingenious experiments, will tell. As the search for parallel realities continues, we may have the chance to peek behind the curtain. But until then, is the multiverse even real, or all just an illusion? So, as scientists wrestle with these mind-bending questions, another possibility emerges, a concept that blurs the line between science and science fiction. Could our perceived reality be a sophisticated computer simulation? But even as we ponder the implications of our consciousness and the role it may play, a nagging question remains. In our quest to understand the universe, have we perhaps overcomplicated things? Is the multiverse even real, or all just an illusion? As the search for parallel realities continues, we may have the chance to peek behind the curtain. What experiments might reveal the hidden architecture of reality? What grand quests lie before us in the coming years? The search for the truth is far from over. One of the most promising avenues involves the ongoing work at particle colliders around the globe. Machines like the Large Hadron Collider straddling the border between France and Switzerland are not just tools for smashing atoms, they are time machines, peering back into the universe's earliest moments. Scientists are meticulously analyzing the debris from these high-energy collisions, searching for exotic particles or deviations from the standard model of physics that could hint at the existence of extra dimensions or new forces predicted by multiverse theories. Imagine the LHC not just as a collider, but as a window, ever so slightly ajar, offering glimpses into realms beyond our own. Cosmological observations, too, are playing a crucial role. Telescopes both on Earth and in space are constantly scanning the heavens, mapping the cosmic microwave background with ever-increasing precision. Those subtle temperature fluctuations we spoke of earlier, they might just be the key to unlocking the secrets of the multiverse. Scientists are hunting for telltale patterns, circular features that could indicate collisions with other bubble universes, scars left on the fabric of space-time from cosmic fender benders billions of years ago. It is an endeavor akin to reading the story of creation etched across the sky. Then there are the theoretical developments, the mathematical frameworks that underpin our understanding of the cosmos. String theory, M-theory, quantum gravity. These are not just abstract equations scrawled on a chalkboard. They are attempts to build a unified picture of the universe, to reconcile the seemingly incompatible worlds of quantum mechanics and general relativity. These theories, though often complex and challenging to test, provide the blueprints for future experiments, the guideposts that point the way towards new discoveries. Think of these theories as maps, incomplete and sometimes inaccurate, but essential for navigating the uncharted territories of the multiverse. But the next frontier isn't solely about bigger colliders or more powerful telescopes. It's about new ways of thinking, of challenging our assumptions and pushing the boundaries of scientific inquiry. Quantum entanglement, that spooky action at a distance that Einstein famously derided, might hold the key to instantaneous communication across vast cosmic distances, perhaps even across universes. What if entangled particles could serve as cosmic telephones, allowing us to eavesdrop on the conversations of other realities? Artificial intelligence is also poised to play a transformative role. Machine learning algorithms can sift through vast data sets, identifying patterns and anomalies that would be invisible to the human eye. AI could help us to decode the cosmic microwave background, to analyze the results of particle physics experiments, and to develop new theoretical models of the multiverse. Imagine an AI scientist capable of processing information at speeds far beyond human comprehension, unlocking the secrets of the cosmos in a matter of days, a task that would take human scientists centuries. The search for parallel realities isn't just about proving or disproving the multiverse. It's about fundamentally changing our understanding of the universe and our place within it. It's about expanding our horizons, challenging our assumptions, and embracing the possibility that the reality we perceive is just one tiny sliver of a much larger, more complex, and more wondrous cosmos. The next breakthrough could come from an unexpected direction, a new experiment, a new observation, or even a new way of thinking. It could be the discovery of a new particle, the detection of a gravitational wave from a distant brain collision, or the development of a revolutionary new theory that unifies all the forces of nature. So where is this mind-expanding field headed? The answer is simple: forward. As scientists search for answers and the meaning behind it all, this journey continues, for there is so much more to explore. But what is your cosmic context in all of this? How does it all change your place in this vast and mysterious cosmic ocean? The search for parallel realities continues. We may have the chance to peek behind the curtain. What experiments might reveal the hidden architecture of reality? What grand quests lie before us in the coming years? The search for the truth is far from over, but it all circles back to you, doesn't it? to your place in this cosmic tapestry, woven from threads of possibility and uncertainty. If the multiverse exists, how does that knowledge, or even the mere contemplation of it, alter your perspective? Does it shrink your significance to near nothingness, or does it amplify the wonder of your unique existence? For centuries, humanity has gazed at the stars, pondering our place in the cosmos. From the ancient Greeks who envisioned a universe centered around Earth to the modern astronomers who map the vast expanse of galaxies, we have constantly strived to understand our cosmic context. But the multiverse, if true, shatters our preconceived notions, challenging us to redefine our understanding of everything we thought we knew. Are we special, or are we an accident? Think about the sheer scale of the observable universe. 93 billion light-years across, containing an estimated 2 trillion galaxies, each teeming with billions of stars. Now, imagine that this is just one tiny bubble in a cosmic ocean, an ocean filled with countless other bubbles, each a universe unto itself. It's a humbling thought, one that can easily lead to a sense of insignificance. How can our lives, our struggles, our triumphs possibly matter in the face of such unimaginable vastness? Yet paradoxically, the multiverse can also amplify the wonder of our existence. Consider the sheer improbability of your own life. The odds of your parents meeting, of their ancestors surviving, of the countless historical events that had to occur for you to be born, are astronomically small. You are, in essence, a statistical anomaly, a cosmic fluke. And the multiverse, with its infinite possibilities, only makes your existence even more remarkable. The odds may have been the same, but that doesn't make your circumstances any less special. In a universe of infinite possibilities, your choices matter more than ever. Every decision you make, every action you take, creates a ripple effect that extends across countless realities. Even the smallest act of kindness, the simplest expression of love, can have profound consequences, shaping not only your own life, but the lives of others in countless parallel universes. Those actions may not matter to the world at large, but it matters to the worlds around you. Look to the words of Carl Sagan, the astronomer and science communicator who brought the wonders of the cosmos to millions. Sagan spoke eloquently about the pale blue dot, our Earth, suspended in the vastness of space. He reminded us of our shared humanity, of our responsibility to preserve and cherish this fragile planet. The multiverse only reinforces this message. If our universe is just one of many, then it becomes even more imperative that we take care of our home, that we protect our planet, and that we strive to create a better future for all. It may be just the start of one world, but it could be the example for an infinite number of worlds. The concept of uniqueness, too, takes on a new meaning in the context of the multiverse. If infinite versions of you exist, living out different lives in parallel universes, what makes you, you? What distinguishes your particular consciousness, your particular experiences, from all the others? Perhaps it is the specific combination of genes, memories, and experiences that make you unique. Or perhaps it is something more elusive, a spark of individuality that transcends the boundaries of space and time. What makes you who you are? One might argue that there is nothing that makes you special, that nothing anyone does matters at all. However, even if the circumstances are the same, there will never be another exactly like you. You are special, in one way or another. Think of the words of Helen Keller, the author and activist who overcame incredible adversity to inspire millions. Keller, who was blind and deaf, once said that life is either a daring adventure or nothing at all. Her words resonate even more powerfully in the context of the multiverse. If we have the opportunity to explore, to learn, to grow, to create, then we should seize it with both hands, regardless of the risks or the challenges. The possibility of the multiverse encourages us to embrace wonder, to cultivate a sense of awe and curiosity about the universe and our place within it. It is so important to never stop asking questions, to never stop exploring, and to never stop imagining. As we contemplate the vastness of reality, let us not be overwhelmed by insignificance, but rather inspired by the sheer scale of the possibilities. Take a moment to reflect on the words of Albert Einstein, the brilliant physicist who revolutionized our understanding of space, time, and gravity. Einstein once said that the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. He, who knows it not and can no longer wonder, no longer feel amazement, is as good as dead. Einstein's words remind us that the quest for knowledge is not just about finding answers, it is about cultivating a sense of wonder and amazement at the beauty and complexity of the universe. If not, what are we doing all this for? Whether the multiverse is ultimately proven to exist or remains a tantalizing hypothetical, its contemplation has already transformed our perspective. It has challenged us to think bigger, to question our assumptions, and to embrace the vastness of reality. It has reminded us of the importance of our choices, the preciousness of our existence, and the power of our imagination. The existence of other yous, other worlds, may remain one of science's most profound and unanswered questions, but the mystery should encourage you to consider the vastness of reality. The existence of those other worlds and other yous remains one of science's most profound and unanswered questions. What is clear, however, is that the future discoveries are just on the horizon. The sheer scale of it is almost unfathomable. To consider that there might be not just other worlds, but other versions of ourselves. And so, we come to the ultimate question, the one that has driven us through this exploration of physics and philosophy. Do other yous exist? The current state of scientific understanding is this. We stand at the edge of a precipice, peering into a fog of possibility. Compelling arguments exist on both sides, but definitive proof remains elusive, a shimmering mirage just beyond our grasp. The multiverse as a concept is a double-edged sword. On one hand, it provides elegant solutions to some of the most perplexing problems in physics, like the fine-tuning of the universe and the mysteries of quantum mechanics. On the other hand, it introduces a level of complexity that some scientists find unsettling, a proliferation of universes that are, for now, beyond our ability to observe or test. The question, then, is whether or not the cure is worse than the illness. The arguments for the multiverse are rooted in solid theoretical frameworks, from cosmic inflation to string theory. These models, while still incomplete, suggest that our universe is not unique, but rather one of countless others, each with its own set of physical laws and constants. And within these universes, the very fabric of reality could be so different from our own that it defies our current comprehension. What would color even look like? The many worlds. Interpretation of quantum mechanics, with its branching tree of possibilities, offers a particularly compelling vision of the multiverse. Every quantum measurement, every decision we make, spawns a new universe, creating a vast and ever-expanding tapestry of realities. It means that there are infinite versions of each of us and infinite possibilities for our actions. But the arguments against the multiverse are equally compelling. The lack of testability, the reliance on speculative theories, and the challenge of the measure problem all raise serious concerns. Occam's razor, that principle of scientific parsimony, reminds us to favor the simplest explanation, and invoking an infinite number of unobservable universes may not be the simplest solution. Can we be sure it's not simply a delusion? The enduring mystery of whether other yous exist pushes the boundaries of both physics and philosophy. It forces us to confront the limits of our knowledge, to question our assumptions about the nature of reality, and to grapple with the deepest questions of existence. Are we alone in the cosmos, or are we just one of countless versions of ourselves, scattered across the multiverse? If a tree falls in the woods, does it make a sound if no one is around to hear it? The very question challenges the definition of you. What is the core essence that makes you, well, you? Is it your physical body, Your memories, your consciousness, or something else entirely? If there are infinite versions of you living out different lives in parallel universes, what is the common thread that connects you all? Could there be a difference between all the branches? And what are the ethical implications of a multiverse teeming with alternate selves? Do we bear any responsibility to these other versions of ourselves? Do their actions reflect on us, and do our actions affect them? These are questions that philosophers and ethicists will be grappling with for decades to come. What if they have it better than we do? As we conclude this exploration, one thing is certain: the existence of other yous remains one of science's most profound and unanswered questions. It is a question that will continue to drive scientific inquiry, to inspire philosophical debate, and to captivate the human imagination for generations to come. But whether or not other versions of ourselves exist, the possibility encourages us to consider the vastness of reality and the sheer wonder of our own unique existence. This then asks the questions: is it possible that everything happens for a reason, or are we just making up stories to make it through the night? Ultimately, the search for the multiverse is not just about finding other worlds. It is about understanding our own. It is about exploring the limits of what is possible, about challenging our assumptions, and about embracing the unknown. Perhaps it is time to look to the future. Perhaps the question of other yous is not a matter of if, but when. It may be science's biggest question, but it might just be our own.